We explore the roles of combined grip sensing and motion sensing during pen+touch interaction on tablets. We sense the grip and motion on the stylus, as well as the grip and motion on the tablet itself. This affords a variety of new techniques that leverage how users naturally hold and manipulate their devices. For example, we can respond to the context that the user is writing by ignoring the touch signal produced by resting the palm on the screen. For illustration purposes, we show feedback of the palm detection as an expanding radar circle. Note that the user can still use the non-preferred hand to produce intentional touch gestures, such as pinch and zoom. To distinguish these states, we combine the fact that the user is holding the pen in a writing grip with the fact that landing the palm on the screen produces a distinct bump signal, recognizable by the motion sensor on the pen. But a barehanded touch, by contrast, produces no such motion signal. We can build on this strategy to bring up contextually appropriate tools. For example, when the user tucks the pen between his fingers, we detect this as a distinct grip. And now bringing thumb and index finger to the screen produces a bump signal, allowing us to bring up a magnifier tool for detailed stroke work with the pen. Meanwhile, barehanded input with the other hand continues to pan and zoom. As another example, a single finger tap while the pen is tucked brings up the pen controls, allowing the user to change pen modes or the pen style. Note that these type of gestures work because the stylus bump signal occurs at the same time as the new contact on the touchscreen. When the user holds the pen ready to write, our system leverages this context to provide drafting tools simply by tapping with the non-preferred hand. Here, the system detects the writing grip, plus the additional touch generated by the hand that is not holding the pen. The user can then tap on the airbrush tool, for example, and orient the pen above the screen in 3D to control the conic section of the spray. Since we don't know the position of the pen, only its orientation, the finger indicates where to spray. This interaction is a good illustration of how the pen orientation is always tracked relative to the tablet. Each component has 3D inertial motion sensors, which we fuse in a common reference frame. Our virtual barrel button lets the user tap his finger anywhere on the pen, which we use with the airbrush to turn on and turn off the spray. The user can also slide his finger as evaluator, which adjusts the size of the spray. To detect the virtual barrel button, we look for a new finger contact on the pen's grip sensor at the same time as the bump signal. But by ignoring other motions, we avoid false positives while regripping the pen. This underscores how we combine the motion sensing and the grip sensing to reinforce one another. We use the tablet grip sensing to provide context of how the user is holding the tablet. For example, we know if the user is holding the tablet with the left hand or the right. If the user picks up the tablet, we can identify that the thumb contact is associated with the hand grip on the back and therefore not an intentional touch. Removing the thumb and then coming back still allows intentional touch interaction with controls on the thumb menu. As another example, we can use the tablet orientation and grip sensing to detect when the user hands his tablet to another user. In this example, this brings up a simplified annotation mode for shared but limited access to the content currently displayed on the device. We have demonstrated a number of techniques that show how stylus and tablet sensing allow us to tailor pen and touch interaction to the context, such as by discounting unintentional palm contact while writing, yet still allowing full articulation of intentional touches by the non-preferred hand. We can also combine these modalities to support contextually appropriate tools, such as the magnifier tool, the airbrush, or the thumb menu, all depending on how the user holds the tablet and pen. Collectively, these techniques illustrate some of the compelling ways that grip and motion sensing can help support contextual awareness on tablets, and thereby open up the potential for a rich new space of expression for natural pen+touch interaction.